Hi, I'm Timur, and today I'm going to tell you about the Constellation 6 puzzles family. Constellation 6 is a trigonal D-pyramid with 3 axes of rotation that lay in the same layer. The angle between the axes is 120 degrees. Each axis of rotation has 4 possible positions. This puzzle was called Constellation 6 because it has 6 stars on its faces. Because we are bound with rotational symmetry, the angles on the faces are determined and cannot be changed. That's why we cannot do anything with the irregularity of the star and turn the round element into a regular pentagon. But let's say, okay, we do not need the rotational symmetry, but want to have a regular star on the face. What do we have to do? We have to stretch the long side of the face triangle to get 36 degrees in the sharp corners and a regular star with a pentagon inside. This leads us to Biaxe. Here the angle between the turning axes is about 130 degrees, and the third axis of rotation was lost because these cards are not plain and we cannot turn it here. Another way to get more regularity is to create the fourth axis. Then the number of stars increases from 6 to 12, and the result is not just a constellation but a sky globe. Here are the 4 turning faces. This solid body is called truncated triaxis tetrahedron. What else can we do? Let's look at the Biaxe. The turning part of the Biaxe is a tetragonal pyramid with 4 possible positions. How about turning it into a trigonal pyramid with 3 positions? Let's take 2 trigonal pyramids and combine them so that 2 faces of each pyramid coincide. That is, these front faces and the bottom faces. They must lay in the same layer. As a result, we get an irregular tetrahedron with 2 reflectional symmetries, that is, along this plane and along this plane. The puzzle that is based on this shape was called Trapentrix. Here we reached what we wanted: 2 axes of rotation with 3 positions for each. An interesting thing about Trapentrix is that it can be inscribed in an icosahedron with all 8 vertices of Trapentrix being the vertices of the icosahedron. So if we build a vertex here to get 5 triangles the same here and 2 vertices here above the pentagons. thus we will get an icosahedron, like here. So the black lines are Trapentrix, and the blue lines are the new edges of the icosahedron, or here the view from the backside. So to our surprise, one kind of symmetry, that is rotational symmetry, turned into another kind, icosahedral symmetry. So, like always, geometry surprised us more than we could expect. This is a Constellation 6 puzzles family. Thank you for watching.